Welcome, everybody, to the first final exam, the final competency exam. This is going to be a lot more intensive than the other competency exams you guys have done. This one is worth 12 points instead of the usual 5. And what we're going to do is we are going to. I know you guys are ready for this. I know you're ready for this. What we're going to do is rather than having you guys streaming or doing any coding or anything like that, I'm going to put up a question and you are going to type the answer. I'm going to count to 10. I'm going to put up the answer. I'm going to count to 10. And when I say go, everybody hits respond. And then if your answer comes in, too late, doesn't count. Okay. So you got to be on the ball. For some of the bigger questions, I might give you more time, but this is just a fun, easy little, 12-pointer competency exam. So when you guys, this one will be a little longer than most because it is free response. So here we go. Question 0, free response. What does this line of code do? And all of the code is going to be compiled under an older standard, a 12-year-old standard, C++11. So you have no excuse not to know it. Professors out there that don't allow C++11. Go with the times. So this thing here, line 0, question 0, this line right here, auto main, right arrow, int, free response. What does this line do? Don't type anything yet. You type it in the chat. What you're going to do is you're going to type it in, and then I'm going to say, everybody ready? And then when I say go, you're going to hit return. All the answers will appear on chat, and then I'll give you guys the answer. And then if you type in the answer after you've seen the answer, it's too late. Okay? Don't edit your answers either. Okay? So like if you edit your answer and I see the edit mark on it, it won't count when I add up the points later on. Okay? Okay. So everybody type. Everybody type. I'm going to give you guys a few more seconds. Everybody type, what is this line of code doing? What is this line of code doing? And for all of these questions, does not compile is one of the possible answers. Okay, I'm going to count. What does this line of code do? What does this line of code do? C++ trivia. Here we go. And everybody hit return. Boom. Doesn't compile. Function declaration with a trailing return type. Nothing. Main return int. Makes main. Doesn't compile. Basically just like int main. C++20 version of returning an int. Yeah, so this is basically no different from writing int main as usual. So this is effectively the same thing. This is called a trailing return type. C++ allows you to put the return type after the thing, and that's useful for situations where you don't know what the return type is going to be in advance. Because if you have a function parameter, like a templated function parameter like this, then you can't use the variables to determine the type until after the parameter list. So you could do like decal type or whatever. Decal type, x times b, something like this. And so you can deduce the type of it from the parameters. Whereas if it's before, you haven't seen the parameters yet, so you can't deduce the return type. So that's why trailing return types exist. For main, it's just people mostly wanting to look cool, I think. I don't know. There's literally no difference between this and your standard int main. So like if you just want to see seem like you're hip and with the times, then I've seen a lot of people typing this non-ironically. This is just how they code. They're always using a trailing return type. So do it to look cool. Yep. All right. But why? To look cool. I just told you to look cool. There's no benefit. It's literally just some people just really like trailing return types, and so that's their jam. I don't know what to tell you. I'm a C++ wizard. I'm not. Yeah, I mean, honestly, like if you want to signal to somebody that you've been paying attention in class and like not asleep for the past 30 years, this is a great way of starting off, and people are like, oh, this person knows modern C++. Cool. So. Can void be a trailing return type? I think so. Yeah, that's why not. All right, you guys ready for to confuse noobs too? That's another great reason. Yeah, if you want to look smart and job security. Okay, you guys ready for question 1? Here we go. Question 1, free response. What is this next line of code doing? Type it out, but don't hit return until I tell you to hit return, because then people will be able to see your answer and copy off of you, and I'll have to throw it away. So we have here integer I1 equals 0. And the line of code that I want you to explain is I1 is minus equals minus 1. So this is a symmetrical thing. Look at the beauty, the pure beauty of this code here. I1 minus equals minus. Amazing stuff. Amazing stuff. Okay. One, two, three, 4, 5. Hit it. -2. No. This is an increment. This is the cool kids version of going I1 plus plus. It's the exact same code. So you're saying I1 is equal to minus equals -1. So this is the cool kids version of saying I1 plus plus. All right. You guys are doing pretty good. A lot of you guys, Kim Castillo, add 1 minus -1 from I1. It'll make it 1, increment by 1. Yeah, good. Good. You guys are doing great on this comedy exam. All right. 10 questions to go. All right. I think you'll stick with incrementing with I minus minus. Okay. All right. Here we go. Question 2. What is this line of code doing? For your response, put in your answers now. What is this going to print? What is it doing? And what is it going to print to the screen? You have to give me both. So I'm going to pause the recording and give you guys 10 or 15 seconds to type this out. And we're back. Everybody hit return, please. Prints, question mark, exclamation mark. Harrison Stokes. It is the old way of getting the vertical slash character. Bishop Hockman. Correct. This is something called a trigraph. Okay. And this has actually been deprecated and removed from C++ in modern versions, although you can still enable it by passing the -trigraph option. Because you see, back in the day, there were people that did not have certain letters on their keyboard. And so, for example, you can still do this today. Like if you write if X and Y, the reason why we have and in there isn't just for readability. It's because some people don't have the ampersand character. And so for those people, there's an alternative operator that you can use. If you look at this code here, just posted by Aaron, this is a thing, right? This is C++ somehow. This is C++ somehow. It's a thing you can do. That's a lambda. That is boss tier lambda right there. If only Megan was here to enjoy the pure beauty and excitement of this lovely, amazing lambda that we have right here. It's like lambda, but just better. It is just elegant and efficient and powerful lambda code right here. It is a artifact of human civilization right there. That is a perfectly good lambda thing. Okay, where were we? Main.cc, yes. And so this is something called a trigraph. And so trigraphs were a way of printing characters that you didn't have on your keyboard. And this is going to print a vertical slash. Okay, it's going to print a vertical slash to the screen. All right. Ready for question number 3? Question number 3. Unsigned integer x equals 1. Y is equal to -1. If x is less than y, so in other words, if 1 is less than -1, then print out A. 1 is less than -1. If x is equal to y, then print out B. 1 is equal to -1. Otherwise, print out C. 1 is greater than -1. And remember, for all of these options, there is an E does not compile option available if this is not something that C++ would approve of officially. Well, actually, not. It doesn't matter whether or not they'd approve of it. It matters whether or not it would compile. All right. So everybody type out your answers, but don't hit return just yet. Give you guys a few seconds. And a 1, and a 2, and a 3, and a 4. All you have to do is type A, B, C, or E. Okay? And return. Hit it. All right. One person got it right. Good job, Pina. Well done, sir. All right. The correct answer is not C, Aaron. Why would you think that 1 is greater than -1? bizarre and absurd. No. The answer is 1 is less than -1. Please. You guys, man. Oh, you're paying attention to in CSI 40. Who was your CSI 40 instructor? Oh, wait, that was me. For a lot of you, at least. Yeah, what's happening here is we have one of the worst decisions made in the C language, which is that if you mix a integer and an unsigned integer, it will convert the integer to an unsigned integer instead of the other way around. And this is widely considered a bad idea. And if you guys didn't know this, don't worry. When John Kolb gave this at CPPCon, most of the people in the audience didn't know it either. Like he had people put up their hands. And these are the people who know C++. Like you got committee members there. You know, Bjarne's hanging out there. You got like professors. You got the world's best, you know, C++ experts from Google. And like we all got it wrong. Like, so don't beat yourself up too much on that one. But yeah, what happens is the integer changes from an integer to an unsigned integer. And when you put -1 in an unsigned integer, it underflows and becomes 4.2 billion and change. 4.2 billion is bigger than 1. So -1 is greater than 1 in this case. Okay. Is this intentional? It was a decision that was made in the 70s, and we've had to live with it ever since, like Paisley's. Okay. Question number 2. Actually, wait. This is question number 4. I was messing with these questions. Okay, I'm going to have to update these. Okay, here we go. Ask alphabetization. Character A, capital A, character capital A is equal to capital B. Character lowercase b is equal to lowercase a. If variable capital A is greater than lowercase b, see out A, B is greater than A. Otherwise, if variable A, which again holds B, is equal to the variable B, which holds lowercase a, then print out B. B is equal to A. And if neither of those are true, then you're going to print out C. B is less than A. So, very simple question. Just checking your knowledge of ASCII. All right. No, don't type the answer. Don't type the answer. Okay. And here we go. Type in 1. Don't type the answer. No, stop. You have to wait for me to say hit it. No. You guys get no credit. Okay. And delete it. Delete it. Yeah. Okay. Hit return, everybody. Yeah. Well, unfortunately, we're going to have to throw that one out because multiple people gave the answer prior to the deadline. So this one is invalid. Boo. Okay. But yes, capital B is less than lowercase a. Capital B is a low number. Capital A is a higher number. So capital B is less than lowercase a. So A is less than B. So C is the answer. Okay. All right. Next. Question number 5. Question number 5. Another question. Ask alphabetization. All right. Don't type the answer until I tell you guys. All right. You have to throw that one out too. You only got 12 questions. It's out of 10, so we can throw away 2 of them, I guess. If you don't, then you get them as extra credit. This is good for competency exam. All right. Here we go. So we have the variable A is equal to capital A. The variable B is equal to lowercase a. If A is greater than B, then output A is greater than A. If A is equal to B, then print out A is equal to A. Otherwise, print out A is less than A. So wait, don't hit return yet. I'm going to count to 5. And 1, and a 2, and a 3, and a 4, and a... Hit it. C-E 3. 3 is not even an answer. There's no 3. 3. C. Fine. All right. The confusion comes from the explanation. Good. You guys got that. Yeah, capital A is in fact less than lowercase a. So that was an easy one. That was a free point. Okay. Here we go. Integers and floats. So we've got here case 6 here. Integers and floats. We've got integer f that's equal to 5.0 divided by 2. We've got float I that is equal to 5 divided by 2. If I is less than f, see out A, I is less than f. If I is equal to f, then see out I is equal to f. Otherwise, print out I is greater than f, or E does not compile. What? They weren't declared? They are declared. What are you talking about? What? They weren't declared? The last one. Yeah. I scrolled down, right? Character A, character B. Part of the same file. Okay. We're all within main, dude. Everything here is within one function. So we have integer f is equal to 5.0 over 2 and float I. Very misleadingly named float I and integer f. All right, on the count of 5, give me your answers. And 1, and 2, and a 3, and a 4, and a 5. Hit it. B, C, A, C, A. All right, the answer for this one is B. It is B. Both of these are going to have the value of 2 in them. So the integer float is going to be, the right-hand side here evaluates to 2.5. 2.5 gets stuffed into an integer, becomes 2. Float I, well, the right-hand side here is 2. Integer 5 divided by integer 2 does integer division, gives you a 2. Sticks the value into I. 2 is equal to 2. Answer is B. All right. Next up, question number 7. Question number 7. All right. So we've got pointer pointing to x. Where's x? So x is up here somewhere. Here is x. We have an unsigned integer pointer pointing at x here. And we say pointer plus plus. This is testing your pointer math knowledge from last time. Unsigned integer pointer equals the reference of x. Pointer plus plus. And then if star pointer is greater than 1, print out star pointer is greater than 1. If star pointer equals 1, print out star pointer is equal to 1. Otherwise, star pointer is less than 1. Give you guys 5 seconds to figure this one out. If you need me to scroll up again and look at the memory up here, x is here, and next to x is y in memory, in case you're wondering. What happened to be next to it in RAM? Might be undefined behavior, but we'll print it it's not, because undefined behavior is not one of the options. E is one of the options. E does not compile, of course. So on your marks, get set, and hit it. A, B, C, or E. Good job. Yes, the answer is in fact A. And the reason for that is because it is equal to 4.2 billion. Because this pointer is pointing at y, and when you dereference y, y is an integer holding -1, it gets interpreted as maxint. So maxint is greater than 1. All right, A is correct. All right, here we go. Hex to integer conversion. So we talked about hex last week too, or this week. Integer foo is equal to 0xff. Integer bar is equal to 0xffffffff. Press F in the chat, please, everyone. And then we're going to compare foo and bar. So who is bigger, foo or bar? 0 times ff for foo, 0 times ff for bar. If foo is bigger than bar, we are going to, and this is not 6, is it? It is 8, in fact. We're on question 8 now. If foo is greater than bar, the answer is A. If foo is equal to bar, the answer is B. If foo is equal to is less than bar, the answer is C. On your marks, get set. Give me the answer. Interesting. The answer is, of course, A. Good job, Hennard. Well done, sir. Well done. All right, so, and Otal also, good job. Obviously, this is the smaller version, smaller number. I think we can all see that. And Eric, yeah, got him. All right, the answer is A. The answer is A. Yep, you got it too, Aaron. Well done. All right. So all ones is -1 in 2's complement, which is how our standard integers are held. So FFFFFF is all ones, which is -1. FF is going to be like 16 times 15 plus 15, whatever that works out to, like 300 or something. I don't know. So foo is bigger than bar. This is -1. This is like 300 or 400, something like that. So it is bigger. Next up, we are going to do this little guy here. And I'll give you guys a little bit more time on this one. So we've got, starting off, we got a Boolean called trip that's equal to false. And then we're going to have a for loop. And inside of the for loop, we're declaring a class. And so we're going to say for class, no name on the class, open curly brace, public, : int q, r, semicolon, close curly brace, no semicolon. Bob equals open curly boy, 1, 1. Bob.q is less than 10. Bob.q plus plus. Bob.r equals Bob.r in the body, in the loop body, however many times this runs. If it does run, if it does compile, anybody's guess. Bob.r is going to be doubled every time the loop runs. And then your goal is to see what the final version of the value is after the loop runs, if it does run. If it doesn't run, you're going to put down E. So every time the loop runs, Bob.r doubles. Bob.r starts off at 1. After the first loop, it's going to be at 2. After the next loop, it's going to be at 4. And your goal is to see, is tripped equal to false or true based on the final version of the value of Bob.r. So I'm going to pause the recording now and give you guys a little bit of time to count on your fingers and toes and figure out what the answer is. Don't give the answer if you know it. Just wait. And we're back. On the count of 5, please give the answer. And a 1, and a 2, and a 4, and a 5. Hit it. E's, A's, B's. All right. If I'm doing my math right, it should have a final answer of 512. So trip should equal false at the end of the loop. So you can, in fact, declare a class in the middle of a for loop. This is allowed. You do not have to have a name on the class. This could be an anonymous class. That's allowed. We're declaring a variable of type, whatever class this is. That's allowed. That's why the semicolon is there, in fact. And we're initializing Bob's Q and R both to 1. So the loop is going to run a total of 9 times because Bob.Q goes from 1 to 9. And Bob.R doubles every time it runs. So it should be 2 to the 9th power, which is 512. So tripped should be false after all that. So job security. There you go. All right. Yeah, it didn't start at 0, started at 1. All right. Next up. Standard library. Test with the standard library. Your standard library knowledge. Okay. So there's a standard library function called iota. And we're going to create a standard C-style array. Standard C-style array named R, value of 10. Every element initialized to 0. And we're going to call iota on it. See if you remember this from like a couple days ago. It's going to iota the function from the beginning to the end, starting at 1. It's going to then do a try-catch block. So if an exception is thrown, it's going to print out D, throws an exception. Otherwise, it's going to print out one of these things. So depending on the value of 4 square bracket R with 4, is it greater than 4? Is it equal to 4? Is it less than 4? So I'll give you guys a few seconds to think about this. E is always an option. 4 does not compile. So if 4 square bracket R is greater than 4, then you're going to print out 4 square bracket R is greater than 4. Otherwise, 4 square bracket R is equal to 4. Otherwise, 4 square bracket R is less than 4. Give you guys 5 seconds. And hit it. Good. And the answer should be A, because iota is going to initialize R square bracket 0 to 1. So R square bracket 1 is 2. R square bracket 4 is 5. And so R square bracket 4, which can also be written as 4 square bracket R. Remember, this is because of pointer math and the syntactic sugar, you can actually write R and 4 backwards with each other. It's garbage, and people will hate you if you do it, but it's great C++ trivia. So the one here starts at 1 instead of 0. Yeah. So in this case, this for R is 5. 5 is greater than 4. The answer is A. All right. Let's see, 8. So this one's actually 9 here. Forgot to update these numbers. I've given this test many times. Students, I've only had, I think, 1 student actually pass it. So if you're not doing well, don't worry about it. All right. So variable shadowing. Here we go. All right. Bob is equal to 5. Integer x equals 0. Int Bob equals 12. Cout A, x equals x. Else if int y equals 1. Cout y is equal to y. Otherwise, C x is not equal to x, y is not equal to y. So we're making variables inside of an if statement right here. We got Bob. We got several Bobs. Remember, there's an X still up above as well. And so you need to figure out, is it going to print out A, X is equal to, I guess, 0, B, Y is equal to 1, or C, X is not equal to 0, and Y is not equal to 1. On your marks. Get set. Get super set. And hit it. And the answer is B. Very good, very good. Because when you do this, it's going to return true. 1 is true, 0 is false. And so it's going to skip over that block. It's going to set Y. It's going to declare a variable Y and return 1. And then it's going to return, it'll return true. This returns true. Okay. So maybe none of you guys are saying compiler error because you're smart, or maybe because you're looking at the commander of completion. One way or the other, no more commander of completion. We are in nano mode. Let's do this. Let's go. Okay, comma operator. So x is equal to 5, y is equal to 10. If x equals y, false. See out A, x equals y. And if you're looking at like last year's test, I've changed most of the questions, so it's probably a bad idea to do so. You can probably find this video from last year when I gave it. I've changed most of them though, so they have different answers. So x equals 5, y equals 10. If x equals y, comma, x double equals y, comma, false. See out A, x equals y, x double equals y, false is true. Otherwise, see out x equals y, x double equals y, false is false. I'll give you guys 5 seconds to come up with A, B, or E. E would be does not compile. On your marks, get set, and go. All right. In this case, it is false. The answer is B. And the reason for that is because the comma operator, which you've seen before, like in declaring variables, the comma operator is like a semicolon, but it can be placed within an expression, within parentheses. And so this is useful in cases where like you want to have a function, like a void function. Void functions normally cannot be put within an if statement because they don't return true or false. And so what you can do though is like call sort or something in an if statement, and then say comma, if the first element is 10, then do something, otherwise do something else. And so this allows you to do things like embed void functions into if statements. The way that it works is that it does this command. It's like you have a semicolon, it does that command, then it does that command, and then the entire expression evaluates to whatever is the last thing. So the whole thing evaluates to false. Okay. I always find these if statements weirdly looking. Like sometimes what's the point of these kinds of if statements? Like I said, like sometimes like you'll see people do function call, like a void function inside of an if statement, and you can use the comma operator to do something with the results of the function. I don't write code that way, but I've seen it. Okay, finally, bonus round, numeric literals, analog literals. So if I minus I is greater than I minus 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 I, see out I, A, I minus I is greater than I minus 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 I. Otherwise, if I minus 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 I is greater than I minus minus I, see out I minus 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 I is greater than I minus 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 I. Otherwise, print out I minus 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 I is less than or equal to I minus 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 I. Or E does not compile. All right. On your marks. Get set. And go. All right. The answer is, in fact, B. Yes. So analog literals, the value is based on the width between the two i's. And so in this case, 5 is greater than 3. And so this number here is bigger than this number here. You want to look at analog literals. You can actually declare variables that are lines. You can declare variables that are rectangles. You can declare variables that are 3D ASCII art. And you can see that this 3D ASCII art here is bigger than this 3D ASCII art here. So you can actually compare these two things using the analog literals header file. And that is everything. So if everybody could please go back and count up your score, post your total score here. The way it's going to work is you might have zero. You might have guessed that this is a troll exam. It's in a directory called lols, but it was actually going over a lot of the stuff that we talked about this semester. So the way it's going to work is this. When we actually give you your real competency exam on Monday, if you got a higher score on this one, and you take your score and divide it by 2, because this is out of 10 questions. I gave you 12, but I'm going to make it out of 10. So if you got 6 questions right on this, then if you get worse than a 3 on your next competency exam, you'll get a 3. So on the actual competency exam, you will get the higher of your score here tonight, today, or what you get on Monday when we actually do the competency exam for realsies. So I can run the code if you want. So the first thing is vertical slash. A, 1 is less than -1. B is less than A is less than A, I is less than F. Yeah. So the I minus equals 1 is 1. It's the same thing as I plus plus. So I minus equals -1 is the same thing as I plus plus. That's the answer for that. Here's the answer key right here. So you can go back through your history, and if anybody got over a 6, let me know. Most students get somewhere around less than guessing on the test, because this is deliberately done to kind of poke at the less well-known parts of the C++ standard. So all of this is designed to sort of like show you guys some of the messier things you can do with C++. And this is not even the worst. I have another one for next semester. I hope you guys come back and take CSci 26 with me. We have another one of these extra credit C++ trivia hell questions from Doom ready to go with you guys in 26 next semester. So if you got more than a 6, you need a 3 on the next to get 100. No, you get the higher of the 2. So if you get a 2 on your next competency exam, you'll get a 3 if you got a 3 on this one. So if you got a 10 out of 10 on this one, you got a 5 out of 5 on the next competency exam, and you should probably message me right now because I'll just punch in your score now. A 2 or 3, yeah. Basically, my advice is to not worry about it unless you really do badly on the next competency exam. In which case, go back through the log here and see how many questions you got right. Okay, I'll post the answer key here. This is not the final competency exam. It is. It counts. I mean, it is. But there's going to be 4 retakes on it, and so you'll get the. You can think of it as just being one of the retakes. How about that? So whatever you get higher, it counts. Okay. So if you do worse on the next competency exam, then you get whatever score you got here on this absurd trivia test.